Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is episode 11 called Wrath Tracing, where, like I've been saying for a few weeks, I want to make these demo scene streams kind of just like opening up the tool and just making some random stuff. Sometimes we have kind of a goal in mind, sometimes we don't. This time I actually want to have a goal in mind, which is basically, let's do a path tracer very similar to the one in this 4K that was released at Revision called Absolute Territory. It's by Prism Beings, in particular by a guy by the name of Nobi. Awesome dude, funny Finnish guy, makes awesome stuff. Basically, I was really inspired by this 4K for a lot of reasons, not excluding the fact that around 2012, I actually played with almost exactly this kind of tech, but with not nearly the kind of finesse that he had in this and the kind of style that really brings this all together. If you guys haven't seen this 4K, I highly recommend it. I'm not going to watch it here because I don't want to stream YouTube while actually streaming, but I can share the Poet link here. Particularly, this is implemented with path tracing, so it does GPU path tracing. I don't know how many bounces he does or how many rays he does per bounce or that kind of stuff, but what I want to start with is just throw together a really basic ray tracer, and then from there sort of extend it to do this kind of basic path tracing with lots of patterns on the walls and stuff. In particular, one of the earlier tests that Nobi put up on his Twitter just had a couple planes, and then one of the planes was projecting patterns onto the other stuff. So we're basically going to build that kind of scene, I think, first. But totally inspired by this stuff, looks awesome. And I think we can get a basic test version of this up pretty quickly. It shouldn't be terribly complicated. So I think that'll be pretty nice. And the fun part is, because it's in the tool, we'll still have our full post pipeline and everything, so it might be fun to play with. But we'll see how it goes. So that'll be today. By the way, the name Wrath Tracing is literally just path tracing, but with a pun, because I had to come up with something last minute, and I thought that sounded funny. By the way, hi to people in the chat. Trilater, Zokwar, Local Hoster, Dark Second. Local Hoster, there's someone have a ball in mind. Yeah, guys, check this out. It's a shape, but it's like the same distance everywhere. Gonna make that. Dark Second, how is path tracing different from ray marching? Basically, so ray tracing is sort of the basis of path tracing. So ray tracing is where you have sort of an eye ray, and you will intersect it with the objects in your scene. And normally what you'll do when you hit the surface there is you might like project a couple of reflection rays off of that and try to calculate some reflections. In the case of path tracing, what you do is when you have a hit, you actually trace like 10 more rays. So you get a ton of rays going per pixel, easily over 100. And you normally need so many for it to converge into an image that isn't particularly noisy. But one of the fun things about this demo stylistically is that it kind of just lives with the noise. It makes makes everything really flashy and everything really dark, and kind of gives this really cool vibe by just letting the noise happen and sort of letting it be kind of film grainy. Anyway, whether or not we'll get ours this good in a couple hours has yet to be seen. Not making any promises, but should be a decent goal to at least get something kind of close to this. Also, totally check out that 4K because it's really cool. Hey, Arthur Carlson. So what I have here, I didn't have time to really prepare for this show because I was working on a different project. So I basically just have last week's project still open here. And I'm just going to clear all that out, including a lot of the ray marching stuff, because it's going to be a fairly different algorithm. So we're just going to delete like a lot of this stuff here. Including all these uniforms and basically everything. Oh shoot, I forgot to up my font size. Sorry about that. Fix that really quick. Told you I wasn't that prepared. Sorry, I'm getting witness. Links are still disabled. Metal Voids, how's it going? Giant Jelly Mat, awesome. Really happy to hear that you're... Yeah, sorry, I'll read that comment out loud. Hi, Ferris, I'm getting into the demo scene because I've been watching your streams and it looks like so much fun. It is so much fun, and that makes me super happy to hear, so thanks for sharing. Also, are you the guy that tweeted me the other day looking for VST advice? Because if so, I'm sorry that I didn't have many tips for you, but I'm very happy to hear that you're working on a new synth. Cool, good to see you. Dark Second's been playing with a shader toy kind of thing in Rust. Yeah, you can get pretty, basically you can have the same kind of functionality pretty quickly. And it's kind of nice to have it locally. I find like shader toy is kind of neat, but I don't like the compatibility issues that come with using WebGL. There's a bunch of other kind of things with it, but I just like to have it local. In fact, that was kind of the first milestone in this tool as well. It's just like, let's get something that can kind of do what shader toy does, then we'll sort of extend all that. That's nice. Giant Jelly Matt's still having trouble, but I found an example that seems to work, so I'm going to play around with that. Awesome. Yeah, even if you have to hack something together, anything that'll give you a chance to output some samples to a buffer is going to be really helpful. I remember back working on 4K synths where I would just, you have Wave out from Windows, and you can just dump samples into that. Gets us started. Okay, so one of the things we need to do is we need to output everything in sort of the correct format in order to properly work with the post pipeline that I have here. In fact, actually, I'm going to bring back a little bit of this stuff, in particular some of these camera parameters. That should be all we need here. Just so that way these will still be read in from the tool. Of course, we need the uniforms that will actually read these, which are normally in the marching prologue. A lot of this stuff. So we'll just grab all these. And also the layout for the output stuff. Cool. So I'm just hucking bits of shader together. This part is not very important. It really depends on what your tooling and your sort of environment looks like. If you're in a shader toy, you'd already have a lot of these set up, and you also wouldn't have a lot of them, but yeah. Just going to start with something. And then, yeah, we need, where's our entry point here? Oh, yeah, that's in the epilogue. And I'm just going to steal some things here. Get our pixel position and calculate our FOV and our eye direction, all this stuff. Oh, I forgot I had this little camera shake thing here. But then we'll have our eye position and our eye dir, and that's really primarily all we need. And from there we can start actually building stuff. This is missing some other things that we need. In particular, we need some of these. Just pulling in some like rotation functions and those kind of things. And we need the noise functions, which I think will just be like that. Okay, so now we basically got an environment, and all I did here was copy some math that basically given a pixel position, which we get from the glfrag chord variable, and then our incoming resolution, we can basically figure out what our, also, yeah, specifying in a field of view, which in this case is going to be 30. Don't need that anymore. Then we basically figure out the size of our frustum, and then we get our direction of all the rays for every pixel. That's what this IDER thing is. Then there's iPause, which is where that ray is going to start, which is basically the camera position, but I do some rotation stuff with it just to place my camera how I want it. And then we'll basically have that. Now at this point, the tool, I'd be surprised if it actually showed anything because we're not actually outputting anything to these buffers. So we need to do that. We can start with just some default values though, just to get something on the screen first. Hey, John Hunter 9. Just setting up some stuff to do some path tracing related things. I think I have in my screen test shader. By the way, forgot about this. This last week, I put up on Shader Toy, like a Shader Toy version of the test project that I made, or the test shader that I made to test the stuff that was on all the different screens in our last intro. So I wanna link that really quick as well. Let me search this up. So I'm about to steal code from the same shader, but the original version. Here we go. Arthur Carlson, do you use Rust in any production systems? Saw in a Rust survey that it's up and coming in production systems, but not in any scale just yet. I'm not, personally. I know some people that are, but I'm not. The company I work for is primarily a .NET shop, so a lot of that stuff. .NET, C++, that kind of stuff. So yeah, so there's the magic. In fact, this include movie magic GLSL has most of that, and then there's all the bootstrapping here, which has just been ported to the shader toy thing. What I wanted to copy, though, is this output stuff, so that we can just start with something out here. This is all going to be crap, though, but yeah. We just want to start with some basic values. All of these things here, by the way, oh, we're actually going to want to change some of this as well. But yeah, all this stuff is just different things that different parts of the pipeline that I have in my tool uses. Really not important as far as what this stuff is. But yeah, we should see red here now. So that's good. A lot of this is just going to be a lot of little setup stuff that I'm setting up just because of the way my pipeline works. And a lot of it I'm kind of just going to hand wave away because I don't think it's very important for the goal that I have in mind right now. But there are a couple passes that I want to get rid of here. So we have some, I called these GI passes, but they're really just like blurring their reflection stuff. Probably hard to read on the stream, but we'll just get rid of these, I think. And then we should be okay. And then we get compilers here because we're calling functions that no longer exist. So that should be okay. However, some of this stuff now is going to be using some buffers that aren't there. So we want to get rid of one of these blur passes here, which allows us to get rid of these extra passes. Gbuffer passes draws into here. And then the field and bloom. Masking target. I didn't even know I was still doing that pass. Shouldn't be that bad though, because I think we just need. This comes from there. Here we go. Bloom downscale comes from this case. What is that error? Yeah, that's wrong. Because now this is going to be our from our gbuffer target. I can't remember which one this is that it needs. We'll figure that out. And the 4S text can be the same thing. It's so nice that the system just gives me all the errors. This is very useful in when I'm changing the pipeline like this. Although, didn't quite look like that did what we wanted. Because we wanted, yeah, first of all, we want to get rid of this indirect illumination thing here. So we're probably going to need to change some of that. Actually, illumination is layout 1. Actually, I'm just going to undo all these so it shows us where they are. Okay. By the way, it really helps to listen to drum and bass when you're doing this stuff. Gets me in that just do it mood. Then I'll just do a little bit of cleanup here. I'm literally just like telling it which buffers feed into which passes, those kind of things. I'm not that terribly important here. Hey, Dino Colin. Metal Voids. 2 months until Nordlicht. I can't say that worth crap. That is the hardest demo party name to pronounce by far. That I know of. I think that's enough, except I did want to get rid of this indirect target here. But I think for the sake of time, I can probably just not have it output that. Although, I don't want to output either of these now. So let's just bite the bullet here. And drop those. And now we got some shader compile errors because indirect illumination and roughness are gone, which is going to be down here. That's correct. And then here, shouldn't were that we got rid of. The second and third ones. These two targets. I'm kind of surprised that didn't give us any errors. Normal in the background color. And I wonder if actually these weren't used either. Yeah, they probably weren't. Let's get rid of those. Getting rid of all the stuff that we don't need in the pipeline here. Can't imagine why we would need those. So get rid of those as well. And if that doesn't cause any errors, then I'm guessing we're good here. In fact, we can even output some stuff that other than just solid red. Like some sinus pattern here. And if we adjust the depth here, we should be able to get it to be blurred with the depth of field. Let me make this sharp. Again, all I'm doing here is just setting up test stuff. I need saturate. I'll just make it here. And then this will be able to show us if we adjust the focus depth here. Then that seems to be working correctly. So it'll be in focus at -10 units, and then anything around that is basically going to be out of focus because we have a really tiny focus range here. Good. So then whatever we dump out of here will actually work properly with our post pipeline. So that's all I really wanted to set up. Good. This stuff is so annoying if you have to recompile between changing this stuff, by the way. And that already, like in and of itself, just being able to change the pipeline like this totally makes this tool worth it. Okay. So now basically we want to set up a path tracer that will output the color here. In fact, I'm even going to rename this. Or we'll do output color, output view depth. I said depth, but I meant depth. And that works. You'll see basically a lot of the time I'll just like output a color just to see if stuff changed and everything. And that's literally like printf debugging for GPU programmers. So if you see that, that's what I'm doing. Okay, so now it's time to do a path tracer. I think I'll stuff this in a different function. So we can do like, yeah, I'll do a struct. And we'll do, I'm not sure what this needs yet. because we'll need a function that basically is like this. So we're going to do, for example, we're going to have our array here at its starting position and its direction, and that's going to return this result here. It's going to have at least a color. So Hunter 9, you should do a stream on Wavesaber at some point. So I did do a stream going over kind of how it worked. In terms of using it, I should definitely do that at some point as well. And I hope to also do that kind of stuff with the stream. Actually, Hoffman and Wobble, not to spoil the surprise, but they've been talking about doing one of those. I'll keep you guys posted. But I think they're pretty interested in making a song live like that, which would be really cool. Okay. I probably messed up the syntax here, but that's fine. Anyway, we need, I think this will be the interface. For now, we can just start with that. Again, just a random color to test that it'll work. And then we can do this. Bam. Didn't like that. Wait, we need... something like that. And now it doesn't like something here. This is the problem with using a lot of languages on a daily basis, is I very often forget syntax. There we go. Just forgot a semicolon. Okay. So with our function here, we need to actually trace some stuff. Let's see. Now, so basically what we do is we need to get an analytic distance between our array and then some kind of object. Now, for simplicity, what I want to start with is just saying we're going to describe our various parts of the scene as just like, we're going to take two planes, for example, and then our whole scene is just going to be made out of those two planes. And we'll worry about things like texturing and stuff at a later time. But basically, planes in ray tracing are described by a normal, which is like the direction they're facing, and then a distance from, I believe it's the origin to the nearest point on the plane. And with those two parameters, you're able to actually describe a plane mathematically, and that's technically all you need. So I pulled this up, by the way. I always look this stuff up when I'm doing ray tracing because I can never remember this math. This is, I'm just going to give you the link here, from Scratch a Pixel, I guess. By the way, I didn't read this before pulling it up before the stream, but it had the right pictures, and I saw what looked like familiar math, so I'll be able to figure it out. But the idea is, where is it here? Yeah, so here you can see like there's a normal and then a distance to the plane, like the nearest point on the plane here. And with those two, we can figure it out. So that's what this P0 is, I think, if I remember correctly. And then the normal. And then, so then this equation here is basically defining that the surface is this. Like for any P, we can take this P minus P0, multiply it by the normal, and we'll get this. And so the rest is just kind of hooking up those equations together. And you can basically figure out this T here. Now, again, I'm skipping over a lot of this stuff because it really doesn't matter too much to us what we're doing here. We're basically just going to rip off this code because it's like you can sit there and draw pictures and understand it. I did that when I was younger. You guys can do that in your own time. But right now I'm just going to steal some code. Cowtail, no, today is a demo scene stream. So I do on Sundays, I stream demo scene stuff where I'm just making stuff. And on Thursdays, I stream emulator stuff. So I'm using a tool that I made in Rust, but not doing Rust specifically. That's all in my fact, by the way. Also, I believe it says Ferris makes demos up there. Yeah, Dana Collin, local hoster is exactly correct. So yeah, so basically we can take the dot product of the what was L here? I need to look at what this L thing was. Okay, so L is the ray direction here. L0 is the ray origin of the ray. So that'll be IDIR and then IPause in our case. T is going to be the output usually. Usually T is used for like the distance along the ray that we travel to get our hit distance. That's what T is here. So the other thing with ray tracing is that it's totally possible for us to have a ray that doesn't hit any plane. So we also need to handle that case. But I'll get to that in a sec. What we'll basically do here is do this. I'm going to lowercase all these, by the way. And we'll do this here, and then this will, yeah, for the initial value. Didn't hit anything. Then we can do this. If we hit, we're going to take the results color. Otherwise, we're just going to take some random color. It's going to be real ugly. Green everywhere. Good. But yeah, so I'm just going to basically copy this code. I'm going to move it to another tab so I can copy that easier. Or sort of port it. Because the math is just so basic that not that terribly important here. Yeah, let's do this. I'm actually going to do this as well. Let's see. Let's do password's result. I basically want to have a structure for describing. Yeah, hold on. I'm a bit scatterbrained, so I may not explain this stuff that well as I'm doing it, but it'll all come together. It'll all make sense. But I may need to talk less as I'm writing this. I want to have a structure that describes if we're just testing hit against a single object, what will give us. So we want the hit, we want the hit points. Call it that. And we want the normal. At the position where it hits. And with that, we'll be able to combine these. And it'll be rad. In fact, with this result, we're basically what I want to do is I want to have like something like this, where we'll have an intersection results and a function called plane. I'm going to lowercase these, by the way, as well. I'm going to call this path trace. I know I'm jumping around, but bear with me here. Nice. So this plane function is going to return an intersection results, and we want to give it the IPause, I direction, and then we need to give it the plane parameters. So we can do vec3 p0 and vec3 normal. And then I usually just do these crap kind of things here to start out with, and that's fine. Cool. So yeah, so what I want to do is I want to have a couple functions, like in this case, just we'll start with just a plane that will return these intersection results. And then to combine objects, we can use multiple of these. So for example, like if we have an intersection result, if we have two different intersection results, which we'll get from testing hits against different planes, we should be able to combine those in some way. Basically take the union, for example, is what I want to do. So I'm going to create a function here as well. Now union in GLSL, by the way, is a keyword. So we're going to do Yeah. I don't want to call it intersection union because union and intersection are kind of, yeah, I don't want to call it that. IR union. Name's not very important right now. And we'll give it 2 intersection results, A and B, and it'll give us basically what'll represent the union of these 2 hit points. Now, since we're not dealing with materials here, we can basically do this. Let's see, what do we want to do here? If neither of them hit, we want to return an intersection result that also didn't hit. So we can do if not A dot hit, if not B dot hit, then we can just return either one. If neither of them hit, we can just return either one that represents not a hit. Otherwise, we're going to return B. Yeah, so if A was not a hit and B was not a hit, we're going to return either one. If A was not a hit and B was a hit, we're going to return B. Yeah, otherwise, we need to return... Otherwise, A was a hit. And then we still need to do if not B dot hit, return A. So actually, we can see some simplification here. We'll do this. If we know B's not a hit, we can return A, and then whether or not A is a hit actually doesn't matter in that case. Because if it'll be correct. So we'll do this. If B was not a hit, we'll return A. If A wasn't a hit after that, which means both of them weren't a hit. Yeah, let's do this. Just to rewrite this differently, we'll do this. Actually, I don't think this is correct because if not A dot hit, we're going to return B. Yeah. Okay. Now if we at this point we know both of them had to have hit, otherwise it would have earlied out in one of these cases. So then we're just going to give a new intersection result where hit is true. And then the hit point is going to be, yeah, we need to figure out which one is the minimum here. So what's cool about this is we can do this stateless. Other than the hit point, I'm going to add another field to this, which is going to be hit distance. So the distance between the I vector to the hit point. And just going to have this return this. And the reason we want that is we want to be able to compare which one's actually closer. So we can take the hit difference is A dot hit distance minus B dot hit distance. And what's cool about this is we can get a step function from this. So if we do step 0.0 hit diff, or is that what we want? Because what this will do is then if A is greater than B, we're going to be, let's do it this way. So if, yeah, so we're going to take the difference between the two distances. If B is greater, that means it was further away. And that means the result of this is going to be positive, which means it's going to be greater than or equal to 0. In which case, the result of this step function is going to be 1. Otherwise, it's going to be 0. So then 0 represents A and 1 represents B. So that's cool. So we can do this. And we're going to mix A dot hit points and B dot hit points with this hit step here. We call this hit step. And we can do the same with the normal. And we also need to do that with the distance. Just a way to do this like step function kind of thing. Stateless. Yeah, that's helpful. So then now if we have a couple different intersection results, we'll be able to union those together and hopefully get the right result. Won't be able to test this until we actually start adding things to the scene, but that should be all right. Just to double check here. Yeah, let's go ahead and implement this properly. Oops, it's just dot. dir and then normal. Actually, it's no, the order here does not matter because of dot products. So what this is giving us, by the way, is this gives us, I believe it's the cosine of the angle between these two angles. And we're going to divide something by this. And so we need to take the dot product of this and store it somewhere, because if we're basically going to say if it's less than some very small number, I usually like to put this in epsilon. Basically, that's going to be like really, really tiny. Then our divide result is going to end up being infinite. And so I like to, yeah, we need to early out in that case. So that's what we do here. That. And then, if that's not the case, we can do this. Like 3. Then this still may not be hit because this can be positive or negative. And as far as I remember, that determines whether or not we're above or below the plane. If we're below the plane, we don't want to count that as an intersection. Or maybe we do, but I don't want to in this case, I think. So then we have if t is less than 0, then we're going to also early out. In fact, actually, what I want to do here intersection results. I call this iron null to match this. Then we're going to do this just to have some kind of struct that represents nothing, basically. Otherwise, this is pretty easy. In fact, actually, you know what? We actually don't need to do we don't need to return in this struct the hit point, because with the hit distance, we'll be able to reconstruct that. And we'd rather not do more work than we have to in a lot of these functions. So let's go ahead and remove the hit point stuff here. And everything else should more or less just work. Everything compiles at least, but we're still not using this. So there's a bit of setup here to do, but that's okay. Almost ready, I think. Yeah, so let's try this. Oops. I'm gonna close my Slack here really quick. Even though you guys can't hear my notifications, still bugs me. Yeah, so we need an intersection results. We're going to call this the floor. Actually, we can't call it the floor because that's a keyword. We'll do plane 0. Why not? And then for this, it'll be a plane where we have the eye position, the eye direction, and then we need this P0, which is going to be the point on the plane that's nearest the origin. So I want to have this kind of moved backwards. Actually, since this is going to be a floor, it's going to be moved downwards. So this is going to be something like -10, like this. So it'll be straight downwards, and then the normal of the plane is going to be straight upwards. Now with that, we can basically figure out if this hit or not. I'm going to put this in a different variable so that we can do everything based off of this, and then later if we combine different objects as a result, then we can just do the combining here, rather than having to change all the code after that. A little bit of forward thinking there. Not something I usually do. And then here's what we do. This will be a null result for this as well. Right, and then here's what we're going to do. We're going to say if res.hit. Actually, we're going to do if it didn't hit, we're going to return the null stuff. Okay. And then we can figure out our hit points, which is going to be res.d. Did I just call that D? I usually call that D. I might call that hit distance. That's a bit better, I guess. So our hit point is going to be our eye position plus the eye direction, which is normalized times the hit distance. By the way, just in case, I want to normalize some of these vectors here. Just to sanitize the inputs a bit. Okay, so once we have our hit points, then we can do, I guess, whatever with it. Lighting, texturing, literally whatever. And we're going to make an intersection result out of that. Or sorry, a path trace result out of that. Now, for now, all this has is whether or not it hits in the color. So we can do true, and then we'll figure out our color here. And we'll just make our color be this. Some function of the hit point. For example, sine length hit point times 0.5 plus 0.5. And we'll make a vec3 out of that. Now we need to use the path trace result, which I believe we did with the result hit here. So I would have expected to see at least some kind of hit as we were facing downwards. So something is not correct here. John Hunter 9, what happens if you normalize a vector? So a vector has like a, can be basically defined by a direction and a length. And if you normally just like define the vector as like a vec3, for example, then the three components of that vector just kind of define both the direction and the length. But typically we only want like the direction component of the vector. So normalizing gives us that. Technically what it does is it remaps all of the three coordinates so that the length is 1. But it'll have the same direction. So that's what normalizing does. In this case, we want like the normals of the plane and everything to be normalized so that our math doesn't get super jank. But yeah, I am a bit surprised to not see anything here. We can also do this, for example, if we just make the color red. Oh yeah, here we go. I didn't give a proper return value here. That would definitely do it. So what did we have here again? We have the whether or not it hit, the distance, and the normal. So we want true, t, and normal. Whoops. Am I getting errors here? It doesn't look like I'm getting compile errors, but this is also not working. So not sure what the issue is here. Oh, hey, wait a minute. That's not where I expected the plane to be. Wonder why that is. Ah. Is that why? This is weird. So we're obviously hitting the thing because we're getting this red stuff. And then yeah, here's our little procedural texturing. But and this is also working correctly. So you can see we can get correct distances. We have this kind of spiral coming from the center outwards. But why it's above us and not below us is kind of a mystery. So you can also see here that when we go above it, we can't see it anymore because we do those early outs if the distance was negative. So that's if we're kind of above the plane. You can also see that there's, half the area of the screen here where we didn't actually hit it. But again, why this is above us and not below us is beyond me. Changing this doesn't affect anything, it would seem. Very strange. So if I make this negative, then we would expect it to be down there. And then, okay, so it looks like some of this is kind of making sense at least, but being a bit strange here. The camera, like the origin and everything, should be the same because we use the same inputs for that. And when you're doing the tracing versus marching, it shouldn't really make much difference what that looks like. Although, actually, yeah, okay, actually, no, I see what you mean. Yeah, I think you're right, actually, because, yeah, our Y is actually offset in here. Yeah, good call. And our Z as well, but that'll just move us here above this. So that already helps at least to get this the way we expected it. This looks correct to me. At least in terms of where we are in relation to this. However, I still had to have some values upside down, so I'm a little unsure why that's the case. Yes, this is going to move it up there. And then why is the normal negative here? That's the weirdest part. So that at least puts us around the origin like we expected, but something is weird here. And it may actually be this, because I've seen a couple implementations where you often want this to be negative. I think that was wrong, though. Do I need to normalize one of these vectors, maybe, that I missed? Don't think so. I don't think that shouldn't matter. I wouldn't expect it to be the IDER because we know that that's correct because again, it's the same that I used in the Marcher. I think here. So we're not actually using the union function yet. That may definitely be backwards, but we won't know until we combine a couple objects. That may very well be backwards, but we're not using that yet, so. Just gonna, yeah, that's definitely not correct. That's so strange. Although when I look at the diagram that they have here for this code, it does look like it's hitting the, like what I would have expected the bottom of the plane to be. Under ask Stack Overflow, yeah. Sure, they'll have the answer. John Skeetle, get back to me. As long as I put it under C#. By the way, if I like increase this, that should move it like below us. So that's behaving correctly. But yeah, our normal is definitely backwards from what I would have expected it to be. Although SP0 by n. It's gonna put it up here, isn't it? Let me Google another one of these really quick. Yeah, okay. I just found another one that's right here from Princeton. Dr. says just invert the normal. I do not want to do that because I want a normal to be what we expect it to be if we add lighting, stuff like that. But I found this where the diagram at least shows the normal facing the other way. So it's very possible that just some of this has to be permuted a little bit, which I'm guessing is just going to be fine. Yeah, like in this case, it looked like it adds those values together with the P0 and then the I origin, or the ray origin. I think I'm just going to take this instead. So our denominator is still the same. But our distance is a little bit different now because it's actually, it's D here. N plus D, P0 TV. Okay, so they've done it a little bit differently, where they, instead of having a P0 here, they have a distance, which is what I actually expected. So let's do that. And then what's nice about that is we can just do 5 here, and then it'll be 5 along this normal. So we should have that for the inputs. This is kind of what I expected, or what I remember from doing this at least. There's a lot of permutations of these kind of things floating around. Doesn't really matter which one to use, as long as we get one that gives us values we expect. So I'm okay with this. And then here, yeah, this is a lot more closer to what I remember. So then our T here is dot between our I pause and the normal plus the plane distance. And it'll give us that. And then this is wrong now. And then we get something that was messed up. Oh yeah, this is negative. And then Really? You are kidding me. That's not okay. I'm pretty sure this doesn't matter either, the direction here. That shouldn't matter because of the way dot products work. TV. I fight with this every time I write a ray tracer. It's okay. Yeah, that's our T by the IDER because it's TV. Our I position in the normal. Divided by the IDER in the normal. So 109, I didn't actually find any reference implementations when I looked around, like on ShaderToy or whatever. Maybe I'll make one at some point. Because there are a couple bits in the paper, too, that were a little bit ambiguous. But I would start with just writing a not enhanced ray marcher. Or not enhanced sphere tracer. Play with that, and then the enhanced one will fix some of the rendering bugs, but it's not... Yeah, I'd get a feel for the algorithm first, and then implement those. Andrew, how's it going? You basically missed me fighting with some right plane intersection in order to make a path tracer. We'll get there. By N. Hey, Trevor, how's it going? Glad to see some poo brain presence on the stream. This will get a lot more interesting as soon as I get this stuff sorted. Okay, so actually all the sources I'm saying are that this is actually correct to have the normal backwards. All right, no worries. That's fine, and then we just need to reverse the normal here. No worries. Okay, so here we have our first plane. We'll do a second plane here as well for fun times. I think that's what we want for this, although hopefully that doesn't give us the one that's back there. Yeah, we need to also intersect this. Call that IR union. Okay. that's not correct, and I'm seeing some evidence that we do have a step function that's backwards there, but we'll get to that. So I think that's actually what I wanted for this one in front of us. That should be good. Yeah, it looks like it's getting the max here rather than the min. Good. There we go. Now we're moving. All right, so here we have our two planes. They were ray tracing. Good enough for starters. One of the things I think we're missing, by the way, is the not doing anything with a fog. I'm going to implement that really quick. Because that'll help. I think, yeah, because we'll have the hit distance from the point here. Do we get the distance from here? I don't think I did that. Actually, we'll make it part of the... I don't know if I want to make it part of the path trace result because of reasons. I think I won't. I can make the distance here, though. Do this here. And then the path trace result here. Distance there. And then our thing here, view depth, does end up being negative, actually. There we go. So now we can see our depth of field is working as well. So we have this sort of integrated in the pipeline. That's nice. And then we'll use this hit distance for the fog as well. Yeah, let's see what my mix thing was. That I had in some composite pass at one point. We're going to do this. I'm going to make this a conditional just because it'll be slightly more convenient. And then, yeah. Now we have fog. Oh, and it gets super jank. Usually get stuff like this if you mess up, yeah, do like POW here, and you don't saturate this. Magic. This is usually you're trying to get rid of Moir? No, definitely not. We are trying to set up a path tracer. But right now I'm just making sure everything is correct and working with our pipeline here so we can get to the interesting stuff after. Trev, yeah, this is a Wrath Tracer. Andrew, what's the difference between ray marching and path tracing? So I explained this earlier, by the way. So ray marching, you're going to like step along the ray and then intersect your objects. Ray tracing is where you have analytic distance. So just given the ray and then an object, you know, without stepping, you just know instantly whether or not it hit, and also if it did, where it hit. And given that, we're going to do path tracing, which is basically when we have a hit, instead of just doing like 1 or 2 reflection rays or whatever, we actually shoot like 10 different rays, and we accumulate light from all those. And we do that a couple like reflections worth of steps. We end up with this really noisy picture, unless we use like thousands of rays, which we are not going to get away with. But it'll look good here. That's like the quickest way I can explain it. Is that you shoot a bunch of rays in random directions. and accumulate the light. Oh, excuse me. Okay. Let's have a not terrible background color here. Look at that. Also going to move things a little farther away because our field of view is not the smallest. Or sorry, not the largest. I'm just going to move these out more. Even more. And I'm also going to adjust my depth of field distance here. And my range I'm going to crank as well. And just as a test, just want to make sure that this is... Yeah, that's what we expect to see. Good. Everything looks to be working. In fact, I'll even crank this for funds. For the lulz. Look how there exactly. Actually, it's not a game of life. The patterns that are on there are actually binary counters, so it's even simpler. So we're gonna do something like that. So instead of using sine of length, by the way, I can add time here. This should at least animate when we move this. It's kind of fun. But what we want to do instead is, yeah, some weird patterns. I think all I'm gonna do. How do I want to do this? I'm going to do some integer arithmetic because why not? Actually, we need this to be correct, but then we'll do... The counter is... We can do int here. Do that. Int shift is fract hit point.x times 8 and then we'll do mask is 1 shift left shift. By 7, 8, so 255, and then we do on is counter in mask. Actually, let's do counter shift right shift in 1. And then we can take and I would have expected to at least get something here. Let's see. Where did we go wrong? Is it just because time is 0? Okay, here we go. We need to do we should get some kind of counting here. Okay, and then we'll do right, because we need these to be different values. Yeah, that's correct. John Hunter and Kreis. Less convenient to do geometry this way, but if we just stick with simple geometry, which would be good enough for this experiment today. It'll be fine. So I wanted to do let's actually just do something like this. Now we're starting to get the kind of counting pattern that we expect, although some nasties going on down there. It's also a bit strange how it's not sharp. Yeah, with path tracing, it's a little harder to describe the geometry, unless you can do it with like triangles. Like with real time, it's harder to describe interesting geometry, I should say. And path tracing is just ridiculously slow, so we're not going to get away with shooting that many rays. That'll be okay. But why are we getting? That's not the depth of field, is it? That's doing that roundness? It can't be. Also, I think I actually wanted to do this here. We could do no, because I still want to do that. Do just to make sure. Ah, okay, so that was actually the depth of the field. That makes more sense. This is not the best way to describe this kind of stuff on your GPU, by the way. Just bear with me. It'll be okay. Do this. Let's do. This is a lot less interesting than what Nobi had initially, but I think it's going to be fine. This, by the way, is a rounding error down at the bottom there. I actually do want to tweak this a bit until it looks not crap. And I think this might be why this sucks. That at least helps. Make that really wide. At least get nice wide shapes. Almost kind of where I want it, but there's those counter shapes. Oh yeah, sorry, local hoster. That the thing on the bottom is like precision errors, like rounding precision. It's taking like the floor of the position, using that to do the procedural stuff. And right there, it's like right on a boundary where it actually does the hit calculation. And it's a little bit discontinuous in screen space, so we get these kind of bugs here. It's precision bugs though. Not really anything we have to worry about per se, but they are nasty. I'm just gonna add some numbers here until I get something good enough around where we're looking. I mean, really all we need is just some weird bit patterns here. Yeah, I can offset Y as well. I mean... Oh yeah, you mean to solve the stuff on the ground. Yeah. There we go. That'll work. Yeah. I just want a bunch of these patterns where we're looking. I'm also going to increase the FOV a bit just to make this a bit easier to see some things. Let us see a bit more. And yeah. Now I want to make this a little bit more sparse. It's spending a bit longer than I wanted to tweaking this pattern, but I think it's going to be okay. Yeah, I'll go here. It's really similar. Messing with stuff until it looks okay. I'm sure the stuff that Nobi did is a lot simpler than this as well. But just kind of throwing something together, it'll be okay. But I wanted this to be a little more sparse. Let's do this. Maybe that works. Oh no, it's still quite wide here. Let's do... Yeah. This looks buggy as shit. But it's the kind of stuff we want, I think, for this. And we'll just sit there and offset this. Yeah, I think that's what we need. Something like that. Hoffman, what's up? Yeah. Make it wider. Yeah, okay. Now I kind of like this. Let's move the camera a little farther back. Not sure I like the motion on this, but that's okay for now. Something going. Let's do. Here, we'll offset this. So we can look around a little easier. Okay, so now I did want to add back some of that doff while we're working on this. Okay. And we'll just increase this a little bit more. Okay, so this basically covers our primary race. But now we want to actually do our secondary race, or whatever airy race. So what I'm going to do is we're going to add a level here or something. Depth, we'll say. And what this is going to do, if I recall correctly, I don't think we can do recursion on this in GLSL. I think we have to do it a little cleverly, more clever than that. In fact, I think we can't do it this way. I have to do it like this. We have to do something like this. We need to bounce a few arrays around and then accumulate the color for this. A lot of this will just be inlined by the shader compiler. And we'll be doing okay. Not entirely sure how that got brighter, to be honest. But no worries. Yeah, looks like we're doing okay here. Oh yeah, because we still do depth as 2. Yeah, that makes sense, actually. So then what we do is... Yeah, that actually makes total sense. If I make this 1, it'll go back to how it was. Yeah, perfect. So now we're actually shooting 2 rays. But we're shooting both rays from the I vector, which is wrong. So what we want to do is this. We want to reflect the stuff. So we're going to say I pause is equal to result.hit pause, or hit point. And IDir is going to be reflect the IDir about the results normal. I can't remember. I don't think we have. Yeah, we actually don't get the hit point or the normal from the path trace result thing. And that's fine. We'll just have to add that. Or actually, we can figure it out with the hit distance. Although we've calculated here, so we might as well return that as well. Do that first. And then we need to return the normal as well, which we should be able to get from the result, or from this result. This had normal. There we go. Now I have 1 bounce or reflection. See that? Doing path tracing cries just for fun. Oh, come on. How's it going? Lots of bro love in the chat. Yeah, also this doesn't work quite correctly with the fog here. Not going to worry too much about that. Not going to be too terribly important. Actually, we could apply the fog in all the reflections, but yeah, not too worried about that. Let's add... Yeah, I should have pinged Nobi on Twitter. I forgot to do that. When do you guys get hit him up? Okay, what did I want to do? Actually, I wanted to move this, actually. So that'll be kind of cool. Boy, the movement on this sucks. But no worries. The other thing I want to do is I want to make the light kind of attenuate based on the depth here. So what we can do here is just divide this by depth. And +1. And that'll make our primary rays a little bit brighter than our secondary rays. By the way, if we just do like 3 here, that should actually net us some additional reflections. Although we're probably not going to have any cases where that actually matters. I think that's what's going on there. So that's fine. If we did... we can add another plane just to test that, actually. Just going to add one up top. I think that's about right. And then it's plane 2, and we can just take the union of that. And I think we're getting both planes like on top of each other. That's why we're getting this kind of fighting stuff. Bit silly. There we go. All right, so now we're getting a plane on the top and a plane on the bottom. And then the plane right in front of us. And then we have some reflections. It's a bit too bright. I'm actually going to do this. Darken those up a bit. So we can see that a little bit more clear. And now if we increase this, we should be able to get reflections of reflections. Like four levels. And this will get pretty mirrory. Cool. Okay, I think we do actually need some of that fog. So go the whole way now. What was I gonna? Yeah, gonna apply the fog here. As we can do it here. We still need this. That's gonna be fine. And then we can mix out here. So we can do the cube color here. And then here we apply the fog. Should have attenuated the fog based on the hit distance. Didn't seem to have, though. We can simplify this as well. Ah, that's why. We don't have background available up there. Just do that here. Yet somehow... Ah. That semicolon will help. There we go. Now the reflections are a bit more well-behaved as we get far out. Neat. This use looks like God rays. Yeah, it kind of does. Really gonna have to fix that motion, but let's go ahead and I'm gonna drop this for now, the depth, the amount of rays we do, and I'm also gonna get rid of this last plane because we're just gonna start with the 2 for now, I think. We'll get to that stuff, Dark Second. That's not the next thing we need yet, I think. Next thing we need is to bounce these rays in random directions. That's what we need. So we're going to do this. So this is like our nominal direction, is this reflection vector. So we're going to say this. It's going to be that. Here's the fun bit. We're going to randomize these. And then we need to do a bunch of these per pixel. Not entirely sure how I want to do that yet. Not entirely sure. We'll figure it out. Because what we're basically going to end up doing is doing something like this. What would my FBM look like? Should be able to have noise here. And we need a vec3 for this. So we can say something like, I don't know, IDER plus depth plus time. Now this is going to get real nasty real fast, I think. Oh, see, that did not do what we needed it to do. We need to take all this, I guess, and multiply it by like 2,000. Something like that, although we're getting a lot of bias here. See how we're already kind of getting that reflective kind of look. Nobody's tweet. That's awesome. There's Noby. How's it going, man? My motion is terrible though. Okay. So, I mean, because what we're going to end up doing is we're going to send a bunch of these rays per pixel, but I just want to make it, because we get this like slanty pattern, and that's crap. So actually, what I think I want to do, could just make a vector here. Depth and time, and we want to add some other weirdness here. As the input here. We want to break this up and have it be less uniform. That's kind of the goal first. This is one sample per pixel. Haven't finished setting up the algorithm yet, Noby. Like this should really be broken up a lot more than this. Could also remove this here, so we just get depth and time, but then it's not going to be random enough. Interesting that that's not making that random enough. This as well, what's going to make it. Vizzy, how's it going? Yeah, it just needs something here that's based on whatever. So we can actually just take the, what was the thing? Dot the hider and the result normal. I don't know, something weird. Need something weirder. All PR is good PR. Like how much to add the random factor is all we really should need for this kind of, like, to define a material in this kind of scheme. It'll be okay. Just want it a little less uniform. I mean, already we're getting kind of what we need. If I just start adding more samples, it'll probably just kind of work itself out. Garments, I've made a lot of very ugly things. And I honestly think that's the whole reason why my stuff isn't as ugly anymore. I think that helped a lot, Trev. No, I don't have any Fresnel in here. And I probably won't, because it's already been an hour and 45 minutes. So probably not going to get that fancy with it. Just want to reflect and add a bunch of randomness. And we should get more or less good enough for today. So here's what we want to do now. We have our primary ray. And I think what I'm actually going to do is, instead of doing depth and have multiple bounce, I think what I'm actually going to do for now... Oh, wait, I can just have a loop here, can't I? Yeah, we're gonna have to move some things around here. Because with this scene right here, we only should really need one depth. Or one... Well, actually, because we'll want some bounce back and forth, won't we? So actually, we'll want to have this be higher. We're gonna start hacking some stuff here. Gonna get real nasty. Let's do the fog in... Actually, let's get rid of this. Let's do the fog in our path trace function. So we have our entire color stuff there. No Sweet Lumpa, how's it going? I'll come, it just bounces with normal, plus some stuff. What we're gonna do... hide that more. Yeah, I gotta mix this elsewhere. Just pull this out up here. Oh, by the way, I have some post here that I want to remove as well, now that I'm thinking about it. Actually, that was a bit much. Then we'll do, yeah, pull that out and then here. Okay. I'll just put the fog thing there so we can call this as many times as we need. Look at that. I'm also going to turn down the fog exponent here and make that a little smoother. Add some shake. Lol. I think it's a path tracer if you don't randomize the bounces, but it's not a very good one. You can optimize that with a by just doing ray tracing. Yeah. Anyway, we want to, the reason I did that is because I want to be able to call this a bunch of times here. Yeah, so we can just accumulate the color like this. We're gonna do, this ends up being the same. So for everyone, we need to do, just trying to wrap my head around how to shape this. Honestly, though, I think the easiest way is if we just like normally trace the primary ray, and then we'll just do a couple bounces for the other rays, and we won't have the other, we won't do multiple rays per bounce. I think that's actually fine as long as we randomize the directions as we bounce. Then that becomes a lot easier because we can basically just do this. Yeah, I think that's how I want to do that. So then I'll just mess with this a bit. I guess that ends up being the same. Actually, we want background here. Yeah, that's what we want. And then I think this will get a lot easier. Normally when you path trace, you actually shoot multiple rays per bounce. Don't think we'll be able to do that because we lack recursion on the GPU. So instead, we're just going to shoot more secondary rays. That'll be enough. And then we don't need to do any of this shit. Right, because we're going to, these are the different bounces, and that's what we'll call this. Let's bounce. Some shit like that. But then we need a couple things here. And if we put this like, yeah, we'll do this. Now this starts to make sense. And we do this. That didn't work. Why didn't that work is the question. So actually, let's do this. If we didn't have any bounces, probably because we're not accumulating the color from the primary ray. So we only got the secondary ones. That would explain that. And the nice thing here is we can do a couple bounces. But here's kind of the key here, is that we want to do a bunch of these. So actually we'll do this. And then we don't need this because we can do the primary result at hit distance. And then we can, here we do that was funny. I can tell you right now, there's very little pride in what I'm making at this point. I'm not adverse to cheating. But yeah, actually, yeah, we do this. One of the things we're failing to do here, though, is this. The noise is wrong. Samples here. It's down again. Yeah, you're right. I should actually reset those. Good call. Actually, that's what this is meant to do. Although I don't think I do it here. Or that's what this is meant to do. Yeah, it gets it from this result here. So that should actually be okay. The bounces shouldn't do it. The sample should do it. Yeah, a lot of those are reasons why I'm working on my own pecker, which is related to the project I was working on earlier today. This, by the way, should basically make it exactly like what we had before. And as we increase the number of samples, this should start looking more okay, but it doesn't seem to be. And I'm wondering why that is, because we should be able to starting to get distracted here. Let's remove this, the attenuation with the number of bounces. Which shouldn't really matter anyway. Okay, interesting. Let's do a couple bounces. Let's reset the results. Takatsuki94, thanks for the follow. Admittedly, I'm not entirely sure why it's getting darker. But as you can see, when I increase the samples, how it gets more random, that's a good sign. Okay. Looks like it's starting to work more properly now. A couple bounces. I think something is wrong with the way I'm doing the bounces here. Ah, hold up. You'd think that would have made sense. Then why is this so much brighter? That's so weird. Oh, you know what? I'm not. Oh, here I am. I am path tracing here. This shouldn't make much of a difference, but we'll stick it there anyway. Yeah, the skewing stuff, it has to do with the noise function not having a proper distribution, which is really common with GPU noise. I'm not terribly concerned about that, just because I kind of expect to see that artifact. But that shouldn't stop us from getting at least the kind of smoother look and the proper bounces, which I'm just not getting, which I'm not entirely sure why that is. As soon as I turn the bounces up, it gets all fucky. That's a bit odd. This breaks out of this loop, right? And that should be fine. That might actually be what's going on here. Would not be that surprised, to be honest. Let's do this. Shader compilers are really dumb sometimes. And very often, you need to do stuff like this. More often than I would like to admit, to be honest. Although I don't think that helped. Yeah, right. So this is zero bounces. This is what we expect to see. Or yeah, no, that does actually make sense. Sample, we're gonna take one bounce. The bloom is doing a little work here, but it shouldn't make too much difference. At least in terms of like trying to debug this. I can turn that off though. This is without bloom. Actually looks a little nicer. Let me try something here. Okay, that's what we expect with zero bounces. One bounce. This looks more or less like what I would expect. I mean, we're taking, in this case, like 10 samples from random directions. And the more I increase this, I'm actually surprised I could go as high as 100. Because that is doing a different path trace every time. It gets pretty smooth. And GPUs are fast. So this is more or less what I would have expected to get here. A little bit of like skewing and some patterns in the noise, but at least this is like the right kind of look that I would have expected. In fact, if we turn down the like amount here that we skew the direction, we'll start getting more of these patterns that start to show up here. A lot of skewing there, but something like this, then we kind of see the reflections more as reflections. Noisy as hell, but that's the kind of thing you tweak over time, which is not what we have as much of in this case. But this is more or less what I would expect to see, at least. So I'm not terribly concerned about that. However, as I add bounces, it shouldn't get darker like this. Because we didn't reduce samples, we reduced bounces. I'm going to put this back because this didn't help. Hey, no problem, localhost. I'm glad you're enjoying it. Yeah, should actually offset this with the eye position. Should do that. I wouldn't have expected it to matter much, but you know, happens. Well, that reduced some of the noise, and that makes sense. That would reduce some of the noise, like per pixel. This at least looks a lot smoother here. I'd be surprised if that solved our bounce problem. Yeah, it didn't. Things got a lot slower, which is actually what I expect. So like I'm ironically happy to see that it gets slower, but yeah, a bit odd. Yeah, again, the reflection's all skewed because of bias in the noise function, and the reason I'm not fixing that is because I don't think that's related to the fact that the bounces aren't working, and that problem's bugging me more. I don't think it matters that we're adding the bounce accumulation, because if this was 0, then we would just add 0 divided by some number to this, and that shouldn't bias the number. That should be fine. So this is about what we expect to see. 1 bounce, 10 samples. As soon as I bump up the bounces, it gets darker, and I really don't know why. Gonna remove this. So here, so we can get the. This should be okay. Let me break. Very strange. It only does that for that first one. That's so weird. So I don't think that's going to be a problem if this goes above 1. I mean, that's kind of the point. We want it to do that. Very odd. Does he use? No, I'm not accounting for anything like that. Cries, no, it really shouldn't get darker because if I add more samples, then each contribution will get darker. And I'm dividing that here. But if I add more bounces, we should only be accumulating light. It should only get brighter. We're not dividing by a larger denominator when I add bounces. We're only dividing by a larger denominator when I add samples. Which is different in this case. Weirdest thing too is as soon as I make it more than 1 like that, then it gets a lot darker. Yeah, that's the problem, is that it really doesn't look wrong. I mean, it's kind of jank that I overwrite the eye position either here, but again, that's to get around the fact that we don't have recursion. And I should be, so I'm resetting it for every sample. So basically I shoot a primary ray. Just going to walk through this, see if we see anything obvious. Do I need this, by the way, the primary IDER? No, I don't. So I take the primary result, which is just the result of like tracing against the scene. And if that's a hit, then I'm going to my accumulation color, add the primary results color. Then I'm going to take a bunch of samples. And so all the secondary rays, that's where I actually start introducing lots of samples. So what I do is I set my result to be the primary result. And that's in order to get the hit point in the normal here. So what we do is we set up the bounce accumulator to be 0 here, and then do a number of bounces. For every bounce, we're going to reset the eye position and the eye normal based on the results of the last results. And we want to overwrite this at the end here when we path trace here in order to have the normal and the hit point again as inputs to the next iteration of this loop where it's going to bounce off of something else. So that's kind of what we're simulating there. In this case, we're going to then calculate the reflection vector. Normally we'll add some noise, but I commented that out to see if that helped. And then we're going to path trace along that new direction from the new eye position. And set that to the new results. The next time in the loop it's going to do this. No, I definitely don't have -1 for some default color. And yeah, I also have the break before the accumulation, so it's very odd. Here's the weird part too. 1 looks just fine. 2 would get so weird. I mean, I can do that, but I like never use negative colors as default colors. I always use like ugly colors as default colors. For these exact reasons, because then you'll know. Like the background color, for example. See, then everything turns green. Very odd. I don't think it's the reflections becoming more specular. I mean, maybe. I'm not really sure if that's what's happening or if something else is happening here. I mean, yeah, like they behave more like they're specular, but I'm not entirely sure if that's the way I would describe what's happening, if that makes sense. Like, I feel like that's describing the artifact, not necessarily what could be happening to cause that. So we do the num samples, we always... Here's... Actually, let's try this. Let's do this. Let's do... Just to make sure it's not something weird with using structs like that. Thanks for the follow, JMX. Where else do we have results? Here. Like this. And then what we'll do is we'll do this. I run into way too many shader compiler bugs to not suspect that. Although, I spoke too soon, that wasn't the case. Yeah, no, that's why I suspect it might be related to how we're overriding these values. That's so strange, though. Because this is the number of bounces, not the number of samples. That really skews when it goes up. Oh, I bet I know why that is, actually. Yeah, it's probably this. Of course, this will mean it's... Oh, wow. Even then, it's still strange. Would not have expected that, actually. Wait a minute. Wait a minute. Eider. Huh. I think I found it. I don't think Eider's were set properly, guys. I would not be surprised. If it were something that stupid. Yeah, JMX, that's exactly what's going on. You come up with a different way to... Still skewed, but now it kind of makes sense that I could fix that problem. Oh, you know what? Yeah, noise probably does return 0 to 1. I was thinking it return negative 1 to 1. Ha! Lol. Yeah, in fact. Hold up here. Oh, hold up. All right. Okay, yeah, because I do noise here. Okay. Here, wait a second. Split this out would make it a little easier to handle. Right, yeah. So this is giving me... It's going to be stupid slow. But we're going to do it. That should resolve the skewing. Right, and now we're not doing... I'm taking I into account anywhere. Heyo. Okay, now things are starting to make a hell of a lot more sense. Yeah, I suspect if we add enough, we're still going to see some of these like plasma patterns. But if you guys are Hackers fans, never fear, I is here. So I wouldn't expect the adding bounces to really make much of a difference in this case now. So here, yeah, so here we want the IDER to be like feeding back here. Here's what we'll do. Let's add another plane. Of course, the fin says best artifact ever. Oh yeah, it's like Jeff. Yeah, I should actually do that as well. I'm just gonna make sure my noise is 0 to 1. So I actually don't think it is. Might be, though. In that case, we're going to want to do that here. Not sure if that was correct. Let me remove the bias and see. So now we skew. I actually think that this was -1 to 1. Although we do get a little bit of skew. Do that. Okay, maybe that was the case. Yeah, it probably was. But then we can normalize this. That should make everything work out a little bit better. Cool. Every artifact is the best artifact ever. Hard to argue with that. Okay, so yeah, I wanted to add another plane here, which I used to have. Just put it back. And I also want to move this up more, this other plane. Lost a pair in there. There we have a couple things. See, we still have some skew here. I'm not really sure why that is, but let's add some bounces. Just see if we can hide it. Right, so now the bounces are actually kind of making sense, I think. Everything got brighter, which is actually what we expected to happen with multiple bounces. And at this time, now it makes sense to attenuate the bounces like this. We'll do, yeah, just do bounce +1. So then that should make sense, and we can multiply this. We can raise this to some power to make it nicer if we want. And then we can do like 3 bounces or something. And at least we got the right kind of effect, I think. I multiplied some color by a big number at one point. We probably don't need that as much here. Now that we're accumulating more. Actually, I kind of liked that. Oh yeah, now we're doing path tracing. Oh. That got slower. I'll just make it grainier. Is the solution? That didn't help. Proper frame rates now. Also, adding this third plane did not help. Like, basically everything we add at this point is going to start affecting speed pretty dramatically. Because that's just how this works. That's so funny. It's not perfect. There's some weird shit. Hey, look at how it adds the noise in there, or the time in there. That was weird. At this point, it's been 2.5 hours. And I don't think I'll do much more in terms of fixing bugs. Now I'm just going to sit here and tweak it until I don't hate it. I don't think it's really going to make much of a difference where we add the noise. To be honest. Because we're either going to reflect around a bumpy normal or change the reflection vector. I guess it would simulate microfacets or something a little bit more if we add it to the normal. But, yeah, we could try it. I don't think it'll affect it, though, to be honest. Can't imagine this would look too terribly different. Yeah, we better normalize that again. Not gonna hurt anything. Yeah, change things a little bit, but I don't think really very much. It's more or less what I expected. These are still a bit skewed and messed up, but I think it's okay. I think it's all right. Yeah, I had to add the air quotes to microfacets. So yeah. Not as cool as the original intro, but given the time frame, I think it's pretty rad. Let's turn the chromatic aberration up to 11. Literally. Add some more bloom. Add too much bloom. Stick a logo in there. Let's see. Let's turn our focus range way down so we get shit tons of bokeh. I think our focus depth is a bit off now. Field of view really messes up the depth of field. That's funny. We could just do this. Lol. And we'll do this. Yeah, DOF in this case is still in post. It's the same pipeline that I have for everything, basically. John Hunter always there with the clips. That looks so stupid. Is that Zuntari? Thanks for the follow. Hey, can you tell I've been working on the Virtual Boy again? Oh, Kama, you're gonna get sick if you put on your 3D glasses. All right. Thanks for following, Novi. I'll be here all week. I'm just kidding. I'm here every week, not all week. I was gonna do this. Just to mess with this a little more before I go. Oh, this sucks. All right, well, I had something that kind of looked cool, and then I totally ruined it. And it made for a fun evening. Cool. I think this is about where I'm going to call it quits. Basically recreated enough of the effect in a couple hours. I think that was pretty fun. Next week I might expand this out a bit more. Or I might not. We'll see how I'm feeling. I think this is pretty fun. Hoffman Logic Coma test card. That's exactly what it is. The popular coma. Oh, yeah. Anyway, special thanks to Nobi for making this awesome intro that I wanted to rip off so bad. Because this is pretty fun. Also, fuck you, man. Because it was just too good. But yeah, as always, thanks for hanging out, guys. This was fun. And I'm back on my normal streaming schedule, so as usual, emulator stream on Thursday, and then back to this stuff, more demo scene shenaniganry, next Sunday. So, fun times. Hey, you're welcome, guys. Thanks again for hanging out. And I'll see you later.